Thank you. I'll start my presentation with a story. What happened is 4 years back, probably like 2014, my manager showed up on my cube and said, okay, hey, Vineet, we have a data file. And since we are building this data lake, and one of the business user wants to see something out of this data file. And I said, sure. So I took the file, uploaded into HDFS put, and create external table on the Hive. And it took me like probably 2 hours. 2 hours, like it was a big table and creating the Hive structure, and it was done deal. Manager was happy, and POC was approved, and it's time for, now let's do it in production since lake is built, okay? So are we going to use any ETL tool? No, because we have to go through the purchasing process, evaluating the product, which one is fit. Should we go with Informatica? Should we go with Talent? There are so many vendors in the market. So, okay, so what should we do now? Okay, how many files do you have? So then we started looking into how many files, what type of files. So I thought, since I'm doing this in the Spark, and you might run into the same situation, some same issues that I gone through. Those are the simple things that you need to see when you're building this Spark code for data migration. So it might help you guys. So let me start with what was the business requirement? Business requirement was to migrate historical data into data lake for analysis. In this process, we might have to do some light transformation on the data. Other requirement was like data science team was very curious about these data files. These data files were sitting all across the enterprise. And they said, we want to see what exactly in these files. And the other requirement was there was some data sitting in the Oracle database on the data warehouse for last 10 years or 15 years. And very few people were hitting the data for previous 2 years. And their goal is to offload that data from Oracle system into this data lake. And while they are doing, they wanted to follow some standards. Standard in terms of which format do we use to store this? Should we go with Parquet? Should we go with Avro? And what should be our partition strategy? Should we store our data daily or monthly or things like that? Okay, this one is the data migration piece from the business side. So next one is, like you guys are all data engineers. So if I ask you, okay, here is the CSV file, write a Spark code, and I want to store this in the Parquet. Oh yeah, it's easy and done, right? So there are like thousands of files sitting in there. We call it GPFS file system. And those are like, some of them are few gigabytes, some of them are like terabyte in size. Some of them have probably 15 columns. Some of them have like 2,500 columns. Some of them has like 60, 70 million records, and some of them very small. So you have seen the keynote. So I heard the term called schema 5 times in the keynote. And it's one of the major issues that I have seen, like in the text file, especially. Some people, they have standard, okay, we are not going to put header on the text file. And some says, okay, we're gonna put the headers on the text file. So I'm talking the migration point of view. Since these files are sitting in the enterprise for last 10, 15 years, and they want to bring that data into the data lake. I said, okay, show me the file. I started looking at the file, but there is no file headers. I said, is there any way I can get the schema for these files? These files were created in 2000. So don't know where the schema is, okay? So this is one of the issues that we see is, next one is, data is not in the consistent format, especially the dates. When you see some people use YYY, MMDD, some people use YYY, MMDD, or there are different formats like. So, but in the Hive, the Hive standard format is YY-MM-DD HS24. I'm talking about the timestamp. So if your date is not in that format, if you load that into Hive, you're going to see null, right? So this is one of the major issues. Another thing is we're talking about 2005, and now we're in 2019. What they did is in 2000 files, the table has like say 10 columns, but in 2019, they removed some of the columns, but they added some more columns. So it's not consistent. You see where I'm going? And there could be like several files. So I was talking to one of the ETL developer. So he like, don't quote me on that, is for every file he has to create a mapping, and each mapping can take like 3 to 4 hours. And you multiply like 3 to 4 hours times like 2,000 files. So you see how much time it's going to take. And the other thing is like target table, some table can be partitioned, some cannot be a partition, right? So, and the partition can be a daily partition, a partition can be a monthly partition, so you have to figure it out. So again, the source data can be few megabytes to terabytes, and you can have thousands of columns. Like the one table, the one file that I dealt recently it has like 2,700 columns. And partition column can be one of the existing column. Like you can pick one of the column, okay, these are the things that you, data analyst will work with you. Okay, these are the columns that data needs to be partitioned on. Or he might say, okay, forget about it. Can we pass this as an argument? Okay, for this file, I want to have partition. I want to supply my own column name. And add that, and I'll supply my value. So use the, so can we pass this as an argument? Sure. So what this framework does, it's a Spark-based framework, is it does all these things for you. So the only thing you have to do is you have to specify where is my source and where is my target, and some arguments. Arguments like where is my file, and it takes care of rest of the things for you. So just one code. You are not creating thousands of code. You're just creating one code for that. So I'm taking the simple migration approach from the data engineering point of view. Is the first thing you do is you create the Hive context. I'm just going to the code, right? So once you create the context, you said, I'll read my text file using Databricks Spark.csv. I have my data frame. Simple, right? There is nothing, no data science in that. And you said write. You said data frame.write, and insert to the Hive table. All set and done, right? But now here the problems arise. So same thing, you go with the XML if you have any XML file. So you just specify your format like XML. And if you have any JDBC, if you're connecting to Oracle, you make a JDBC call, and simple thing, right? So now, see, we talked about schema 4 or 5 times in our keynotes. Everybody was talking about schema, 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 data frame, schema, right? So if you see my previous slide, I didn't talk about schema. So I just read the file. I dump into the Hive table. So where is the problem? So if you see the XML and JSON, no issues, because schema presents on the file itself. As soon as you read it, you already have a column name, it infer the schema, and you're good to go. And you can write directly to the Hive table. No issues on that side. So now in the text file, how to get the schema? So file header is not present. So it can infer the schema when you're reading the file, but how about the column's name? And data from last couple of years and the file format has been evolved. So here you see, if I see a data frame.columns, you see the column comes like this. Go back previous. Like C0, C1, C2, C3, C4, C5, right? So let me go back to the, then I said, okay, we'll explore a couple of options. First option is, can you give me a file as a first line? So I'll treat this as a column name, as the first line as the header. So other option is, can you give me an external JSON file? So okay, I have a JSON, I'll read that JSON, and based on the JSON, I'll create a schema, and use that schema when I'm writing to the Hive. I'm creating a JSON for 2,000 files, 2,500 columns. Not sure we can do that, okay? Option number 3, can you just create an empty table corresponds to a CSV structure? Not sure we can do that. I said, but you're creating a Hive table, right? You already have that create table structure that you're creating a target Hive table. Can I use that and create a like similar table, and I'll name it like table name underscore raw? They say, yeah, it's doable because it's already have a create table statement for the Hive. I say, okay, let me use this as a schema. And then we talk about the fourth option, like struct type or the case class. But again, there is some coding required in that. So you have to go and then read the file and then, but we want to create this framework that works automatically, right? So based on that, we said, okay, let's go with option 3 because it's feasible. You already have a script to create a Hive table, create external Hive table, and I'll use that to create my table correspond to this flat file, to this text file. So first problem is solved, the schema problem is solved. The next problem is, I'm just giving an example. Like in this example, I have 4 columns, and you see in this file, there is no header. That's the standard they have. There is no header, right? So how I'm going to use what I just said is you create a table like file1 underscore raw, and you specify ID string correspond to your text file that you have, right? So, and you are using the same syntax, like create external table file1, and you're adding some extra thing like partition by and things like that. So now on the Spark code, what I'm doing is, here you see that I'm reading this, but I'm saying where 1 equals to 0. So it just read the structure. I'm not worried about anything because I'm focused on the schema, how to get the schema. So now I have a schema. From that, I'm pulling the columns. So once I have columns, so I'm just, whatever the data frame that I created in the previous steps without any column names, now I have a columns, right? So here you see the before column names, you'll see like underscore C0, C0, C1, C2. Now, once I applied that columns, so I have my column names, right? So first problem is solved, good. So next one. The historical file, date format can change over the time. Here you see like the date format they're using is MMDDYY, YY. And this is the file from the 2004. And here you have name, address, things like that. But in 2018, they said, okay, we are going to use a different format. We are not going to use this format. And it's possible, right? And they are using like YYY-MM-DD. And also what they did is they added some few columns. You see that records, like one record has no timestamp, but the third record have a timestamp, and they added few columns. So the files is totally changed, right? So how to handle situation like this? And date format change, new column added, same file, but different date format, okay? So to handle this, I'm going back to the target Hive table. So this is my target Hive table. So I'm focusing on the timestamp, just focus on the timestamp, how I'm going to handle the timestamp. And timestamp can be, in this example, you have timestamp at 3 places, at date of birth, move-in date, and rent due date. This is timestamp. And this can be anything, any places, right? Let's say you have 2,500 columns table. It can be anywhere in between, right? So our goal is to figure out, okay, where are my timestamps? So it's a simple. I have said, okay, wherever the timestamp in my structure, grab those columns. The simple and easy things, right? So now I have those columns where the timestamp is. The next step is how I'm going to convert this timestamp to the Hive standard, right? So for that, what I did is I created a UDF. So what that UDF does, you pass in, I just give you an example here. Like you specify DDMMYY, you pass it to this function, to this UDF, and it returns the Hive format. It spits out the Hive format. And the UDF, what it does, it automatically figures it out, okay, what kind of format you're passing into as an input parameter. Based on that, it spits out the correct Hive format. Right. So now we dealt with the date issues also. So behind the scene, how this like this UDF is written, I'm just going to show you one small example. This is how this UDF, the logic behind the UDF, right? So I'm using the Java time format, date time formatter. So here, whatever the valid format that I can think that exists in my historical file, like mm-/dd/yy, any format that I can think of, I put it in this variable. And this can be built from the file as an argument. So all the format that you can think in the historical file. And so what you're doing is you're just putting in the file. Okay, these are my format that it can exist in my historical data. So, and this is my output format. This is the format I want my output should be. And for this presentation, what I'm doing is I'm just showing you the input date comes like this, 10/12/2019 that I showed in the previous step. And parameter to a function, to a UDF. And what you are doing is one by one, you are reading these formats. So first format, you pick mm-ddyy, and you applied with the input date that came to that UDF, and see, and then what you did is you parse that, local datetime.parse. So if it parse correctly, what it's going to do is going to convert this like DDMMYY into the Hive format. You see that? The return is new date.format, valid Hive format. So the conversion part is done. So if it's not, it's going to return the null. So far, so good. So again, like so when I was dealing with this historical data, I had like 25 formats. So it's going to try one, and then it's going to say, okay, is the valid format? Yes. It's going to return you to the actual date. So this was the major issue. The date was the major issue because what I have seen even in one file, like say you have one file. So in the beginning, they were using mmddyy, but in the bottom, they were using different format. So they were just breaking the law of normalization. You cannot have situation like that. I was not expecting that. And the testers, they were looking like few records, like first 1,000 records. Everything was good. But now they started running some quality control on that. They started doing the group by count, all those things. They were saying some records are coming as null. And I said, why is coming as null? Because I didn't expect that, right? How do you expect that? Okay, you will just look like first 1,000 records. All of them are consistent format, and some of them are like in a different format. So, but this takes care of that. So how to use this UDF in my code? So here you see, first thing I have to see, okay, where are my timestamps? In my target Hive structure, where are my timestamps? So you got the list of timestamp here. Then what you're doing is you are applying this UDF on that column. And like here, what this code is doing is you have first find the timestamp. You have timestamp. It's creating another column calling _TMP with the corrected timestamp. So once the corrected timestamp is done, then it's dropping the original column and renaming it back to the original name. This code is doing that. So now you see you have taken care of the date, right? And so first thing here, you're just creating a temp column, and then you're dropping that temp column and then renaming back to the original one. So date parts is taken care of. So here, before applying the UDF, your data looks like this, 10/20/1975. And after applying the UDF, your data looks like this in the Hive format. So far, so good. Another thing that I have came across is, like when you see the file format, right? So first column, you have ID. Next one is name, address, and date of birth. But in the Hive structure, you have ID, address, name, and date of birth. So these are not consistent, right? So it's not like one-to-one. Okay, name is here on the second position. Name is there on the second position on my Hive. It's not like that. It can be any place you want. So makes sense? So here in the data frame that we have from the previous step, ID, name, address, and date of birth. So when I did the write, and then when I'm writing to the Hive, so here you see the issue. My address is, the name got the address and address got the name because the position. What I did is in the previous step, I said data frame.write, append, and I just wrote it to the Hive table. So you will see where my name is going. Name is going to a different column because both of them are string, right? So if one of them is integer or double, and you're trying to insert the string into integer, you will get the error. But in this case, you are not getting error because both of them are string. Name and address, both of them are string. And here you see, so how do you do that, right? That's another issue that I have seen. So in traditional relational world, you go with this query, right? So what you do is, you to handle the situation in relational world is, you go insert into Hive table, and within parentheses, you say ID, name, and address, and you select ID, name, and address at the same sequence, I would say. It solves your problem, right? So how do you do it in Spark? So first step, what you do is, you read the Hive structure. I get my list of columns. And once you have my list of columns, so I'm doing the select columns, write mode, and insert into table name. So what does it mean? It just doing the same thing that you have in the relational world into the Spark world. So that takes care of your, like this sequencing issue. Next one, partitions. Some of the data can be partitioned, some of the data cannot be partitioned. So how do you handle that? So if the target table is not partitioned, you just say insert into, and then you're done with that. So all good. Now next thing is, let me go back to the next one. So let's say if you have a target table which is partition. So what you do is, let's say first thing is you have a load date, and you want it to have current timestamp. So before you insert into the target Hive table, what you do is you prepare your the data frame that you have, all the partition column that you wanted to use, you just add them into the existing data frame before you insert into the Hive table, right? So here you have a column that's a partition column, and you just write it there. So one thing is, like, partition can be one of the existing column from a file. So in that case, what you do is you get the column, and then you just insert into the table name. And since we are already taking care of the order, so if partition column is one of the column, this is going to take care of this. So second one is the partition column doesn't exist in existing data frame. So I want to pass this as an argument. So what you can do is you can pass this as argument, partition by field and partition value. And before you write to the Hive, you can just say partition by to lowercase and the partition value. So far, so good. And the final step, before inserting into the Hive table, you just take the columns and then insert into the Hive table. And another thing that that I came across is the performance. So some of the jobs were big, and we were getting the memory error. And some of jobs are small. So what we did is we created, for the migration type of jobs, its own resource pool. We set certain amount of memory, certain amount of like resource pool, like you gave the percentage, right? Okay, if I want to give for migration 40% of resources during daytime, but during the nighttime I want to give 80% of the resources. We set the resource pool. Once the resource pool is set, then we divided these jobs into 3 categories. One is the large, medium, and the small. So for the large, the file size is like greater than 10 gig, or where we have thousands of columns. So this is the another thing that we have faced is when Spark was writing these data frame to HDFS, it was creating a lot of files. To handle that, what we did is we said, okay, let's create a repartitioning. Let's introduce the repartitioning, and every time the file size is greater than 10, whatever is the minimum of file size in MB divided by 256 or 50, which one is whatever number is smaller, just create as many files when it's writing to the HDFS. And we set the number of executors, number of core, executor size. It all depends on your cluster size. Like in my case, it was 40-node cluster. So based on that, I set these parameters. And there is, you can just do a Google search. And there is a very nice article from Cloudera how to set these numbers on the yarn. But on the Databricks, I have to see that. And for the medium size, the file size, we said we'll keep it 20. And for the small, we don't care about it because this was not creating too many files, right? So I'm just creating this complete pipeline. So first step is you read the data file, and you created a data frame. So once you have a data frame, you apply the schema that correspond to that file. And once you have that schema, and you did the light transformation, especially the dates, and if you have any other things to do, like converting some like percentage into actual numbers, things like that, you can do transformation in the Spark code also. And then next step is you add the partition column wherever you need to see, okay, is this table partition? Yes, it is partition. Okay, what do I need to do? What columns do I need to add into my data frame to make it partition? And if it's not partition, that's okay. If it's partition, that's okay. It works for both. And then you write to a Hive table. Once you write to the Hive table, and the data sitting in the Hive. So I'm saying Hive, but this can be applied for anything. So this is like generalized utility. And with that, any questions?
All right. Thank you so much, Vineet, for the talk. And yeah, this was the last talk for this summit. So I hope you guys had a great summit. If you guys want to queue up for questions, you can queue up over there. Otherwise, you can also just raise your hand since there are not that many people over here. I can also just walk up over to you.
And if you search like on the like on the Google, like I didn't put my GitHub and this code, everything. How to run this code, Spark Summit. And once you're using this, just say GitHub Vineet Kumar, you'll find me on there. And it's pretty neat utility. Like initially, when we asked like ETL developers, right, they were saying, okay, we have to create mapping and all those things. And then the dates were bugging them how to handle these dates. So then when we started working in this Spark, we were done in 15 days. And we were able to migrate like terabytes of data into the data lakes without any issues. So,
yeah, just one question on where you mentioned that in the database world we can do select and insert. But what if in 2005 you only had 5 columns, and in 2019 the same data set gained columns? How do you handle that null or where the value was not present?
Exactly. So if you see this, right? If you see this, so what you're doing is you are creating like you're getting the columns. Let's say if some columns added, some columns dropped. So first step is when you have a file, you want to make sure the Hive structure corresponds to that file, right? So if they have dropped some columns, yes, it's going to put the null on those columns does not exist in the target table. If they have added some columns, what you do is you create your raw table, and then you add those columns, and this statement is going to take care of that. Because first step, what you're doing is you're getting the list of columns from the target table, like ID, name, and this. And this step, like select column star right here. So you're creating that list in the same format that you have in the target, and then you're inserting it. So I think if you play with this code, then you will see how this magic is happening.
Or walk over, whatever you find convenient.
Cool. Thank you, guys.
Okay, great.